Wow. Well, thanks, Jim, for the intro. My name's Solomon. I'm the founder of Docker and a company called .cloud before that. So I heard Jim asked who knows about Docker, but I'm going to ask again because I didn't see the hands. Would you mind just showing me? All right. OK, so most of you know about Docker. So today I want to talk about Docker, but more importantly, the underlying trend in software development and systems in general that is the reason why Docker exists, and the reasons why, the reasoning behind Docker, right? Our goals, our design philosophy, et cetera. So I have another show of hands to do. If you read this, which is the real quote from an email I got, could you raise your hand if you feel like this applies to you? All right. Yeah. So yeah, Docker is popular. It became really popular really fast. And that's a good thing, because I'm here, I get to talk to you about it. It's also, in a way, a problem, because most people today who are aware of Docker have not experienced it directly, I think. And as a result, they haven't been exposed to the design philosophy and really the reason Docker exists, right? So it's both a good and a bad thing. So I'm here to talk about, hopefully, the things that that you hear about less often about Docker, right? So I'm not going to talk about the shipping container analogy, because we've been very good at explaining that one, right? A standard unit of shipping something, that's very useful. But I want to go beyond that. Before I go any further, I just want to take this opportunity, since we're here at LinuxCon, first to say I'm really, really proud and honored to be here. And second, since I know a lot of Linux contributors and maintainers are in the building, to acknowledge the fact that Docker would not exist without this incredible foundation that we have that we're building on top of. And if you guys could join me in a round of applause for everyone who's built Linux. So yeah, I'm a big fan. So let's talk about this trend and the reasons behind Docker. But just in case you didn't follow the last developments, just to give a sense of what I mean by the internet won't shut up about it. Docker is very, very active. There's a lot of buzz around it. There's a lot of people contributing a lot of patches to it. There's about 500 contributors. We've received over 7,000 pull requests. There's 14,000 Dockerized apps, what we call Dockerized. In other words, an application that we know of that has been outfitted at the source code level to be automatically built into a Docker container. And the one that impresses me the most is that there's been 250 meetups in 90 cities, people getting together in real life to talk about Docker, show each other projects, hacks, et cetera. And this is a graph that the events team, the people who help organize meetups around the world, shared with me about how fast this happened, right? So just keep this in mind as we talk about everything else. This is something that happened very fast, and a lot of people are just incredibly excited about this project, and we're basically trying to keep up. This is another graphic that gives a sense of what's going on. This is a snapshot of all the different projects and organizations that we know of that are either building something on top of Docker or integrating with Docker very tightly. So you can see there is everything from platform as a service to continuous integration tools to Linux distributions, cluster management tools. I think there is 4 different talks today given by some of the people behind these projects. So if you want a different perspective, I encourage you guys to attend that. So the summary here is that Docker is very popular. It became very popular very fast, and we're not always sure why. I think that's the question that I get the most. So setting that aside, I want to talk about the underlying reason. And my personal theory about why Docker has become so popular so fast is that it was just in the right place at the right time for a trend that is much bigger than Docker, and that is very important, I think, for all of us. And it's a trend that has to do with how applications are built, right? So if you're writing software today, chances are this trend is important to you. And this is my best possible way of summarizing it. This is what users expect today. right? If you're using Gmail, using Uber, using anything that's online, as a consumer of software, you expect it to behave basically like the internet, right? You expect an application that is a service, that is just always there, it's always on, 24/7, it's globally available, right? From any kind of device, it's not attached to one machine. It works whether you're the first user or the 1 billionth user. Basically, it's undistinguishable from the internet, right? And if you ask a lot of people who use software every day, what's the difference exactly between Gmail and email and their other favorite online application, it becomes very difficult to explain the difference because really, increasingly, people don't want there to be a difference. They want the application to be like the internet. And that's a problem for developers because the internet is a very reliable thing and it works really well. And everyone else is here trying to make their application work on one machine still, right? So that's really the trend, right? I, the developer, need to create an application that runs like the internet. And to do that, I need to somehow decouple the application from the underlying machine, right? I can no longer hand the user a few bits and then they install those bits on one machine and then they're happy. Somehow the application has to be everywhere and nowhere, right? A machine dies, another machine can take its place. We're deploying to a new location in the world. Now the application is also there. All sorts of technical problems that have a solution, right? The technology exists to solve these problems, right? We know how to build distributed systems. And again, a lot of those solutions are built at the kernel level, at the very fundamental system level. And a lot of development teams around the world use those tools to produce kind of a solution to their problem, right? The problem is that everyone is kind of reinventing the wheel in their own way. And you have large web companies, for example, that have hundreds of engineers that's all they do. They build tools to make it easier to create these distributed applications, right? And as a result, there's a lot of waste, right? A lot of people are just reinventing the same tools over and over again, when really 90% of the time there's a standard set of components that could do, right? So that's really the problem, right? The trend, everyone is looking for this, a sort of a standardized way to build these distributed applications that, in a way that leverages the available system technologies, right? But packages them up in a way that is accessible to application developers. So really, that's the problem we're trying to solve. And the best way I could describe to you what we're trying to do with Docker is to provide this toolkit, right? To provide developers with a toolkit to build these distributed applications. And we want to do this in a very specific way because that's been done before. A lot of people are trying to do that. And that's precisely it. Developers are a very diverse group of people. And not everyone wants to build their applications the same way. And although there's a consensus that, OK, if I'm building an application that's going to be available online anyway, it needs to be this distributed system, really. But not everyone wants to build these distributed applications at the same pace, in the same way, right? I want to build this on my terms. Maybe I have an existing application. I built it in a very different way, and I know I need to transition it to this new model, but I can't just throw everything away right now, right? So really, that's the fundamental design decision that we made, is to, instead of providing a large monolithic thing that solves all of your problems end to end, but you have to buy into all of it right away, which means you have to throw away a lot of your existing tools. It's an all-or-nothing proposition. We went the opposite route. We try and continue to try to break down that toolkit into the smallest possible, the set of the smallest possible tools that can help you in different areas. And it's very important to us that you don't feel obligated to use all of it, right? So we spend a lot of time turning Docker into a good ingredient, right? And I'm going to go over a list of the different kinds of problems that we're approaching. But that's really, like, underlying all of this is this essential design philosophy that you should not be obligated to use all of it. And as a result, if you ask 10 different people what Docker is, they might give you 10 very different answers, right? I've heard that Docker is an LXC wrapper, right? I've heard that it's a packaging system, right? I've heard that it's a service discovery layer. I've heard all sorts of stuff. But that's a good thing. And again, remember this slide in the beginning about all these different projects that use Docker. They don't all use Docker in the same way, right? So what are those problems that we approach, that we try to solve? So the first one, and I guess this is where I talk about the shipping container after all, is how I package and distribute the components of my application, right? And remember, we're talking about building a distributed application, so there's lots of machines potentially. I don't know necessarily which machine will come next, right? And so as a developer, I need to produce, I still need to build and test and version and ship the bits that compose that are my software, the executable bits, and I want to do that in a way that the widest possible array of machines can run it, because I don't know in advance what will run it, right? And so that's really, I think, probably solving this problem is what Docker is best known for, because, again, the shipping container analogy, that works. But yeah, in a way, Docker is a packaging system of its own, right? It provides tools for specifying exactly from source how to create essentially a tarball, except it's a tarball with extra metadata and versioning and a particular way of transferring a new version with minimal overhead. I had to make a call, by the way, on the level of technical detail in this presentation. There's too much I want to talk to you about, so I will try to open a few discussions, and what I'm hoping is that after this talk, we can hang out and dive in. So forgive me if you want to hear more technical details and you don't hear them here. The second problem that we try to approach is the problem of a sandboxed runtime. And that's really coupled to the first, which is packaging and distribution. You can't really separate these. We try to separate as much as possible. So it's possible to use the packaging and distribution aspect of Docker without the runtime aspect. But this is where you see the largest multiplication effect of benefits if you use them together. Because you can package more bits in a more useful way if you can make assumptions about how those bits will be executed on the other side. So this is where, obviously, Docker leverages the features of the Linux kernel, C groups, namespaces, et cetera. And the idea is to provide the application developer with a contract, right? A known abstraction, so that the developer, when writing their application, can think, OK, this set of facts will always be true everywhere my application runs, because the Docker runtime will make sure that it's true, regardless of what's underneath. So this is where we define abstractions like exactly how are network resources exposed to the process, right? How do you set environment variable? How do you access the file system, et cetera? And again, we leverage underlying kernel primitives very heavily. Another problem that we're trying to solve with Docker, and that's I would say we're entering the territory of the next few months, right? The first two topics, that's really what we've been focusing on for the first year of Docker. And now, based on everything all the feedback that we got from everyone using Docker, including in production now, this is a list of the problems that we're focusing on now, right? So one very important problem is, very quickly, if you're building a distributed application, you realize, OK, well, the entire application does not fit in one container. There's a database, there's a front end, there's a back end, there's lots and lots of components. And as you scale, one logical component will be made of multiple containers. So how these containers communicate with each other becomes very important. And again, we have the situation where the building blocks are basically there, right? Linux can do incredible things. You have incredible solutions out there for software-defined networking. The array of system technologies available is incredible, and that's kind of the problem from the developer's point of view. There's too many options, and there's no standardized way, really, for the application to consume those. The only reliable constructs I have are, okay, if I have an IP address, then I have IP connectivity, right? If I know which port to connect to, I can probably assume I can establish a TCP connection, right? But in an environment where you have potentially dozens or hundreds of individual components that need to know about each other and discover each other, and that topology is very dynamic, then that abstraction kind of isn't sufficient, right? So we spend a lot of time digesting all the different ways that people hack Docker today to do their plumbing, and then gradually what we do is we pull in the patterns, and then in the next revision of Docker we say, okay, this is the place. And so if you're interested in the immediate future, one thing we're doing right now is piggybacking on DNS increasingly, so that using the Docker API, you can specify which container should talk to which, and then at the DNS level, that's made available to the application. And then if you need more capabilities, for example, watching for changes in the real time, we're exposing a custom API that, again, is optional. If you want to ignore it, your application can safely ignore it. Piggybacking on this topic of networking, pretty quickly you enter the wider topic of clustering and composition. The word orchestration is used a lot. We go back and forth on whether that word should be used, if it accurately describes a technical concept. But really, on the ground, when you're using Docker, pretty quickly you hit two fundamental problems. One is that you're not running, again, these containers on one machine at a time. You want a cluster of those machines, right? So I'm a developer. I want to run this logical unit, this logical software component, but I want it to be spread out across potentially hundreds or thousands of machines, right? So how do I do that? And the second problem is composition. How do I manipulate an application made of 10 logical components as a whole, right? How do I upgrade it? How do I add a component? How do I express the wiring? And so that is built on top of the networking construct I just talked about. And so, again, opening a thread here, this is a major focus of the next 3 or 4 releases of Docker. We are adding a lot of material to allow developers to specify their application as a whole, even if it's made of multiple containers, package that up as a whole, dispatch that on a group of machines, et cetera. So you expect to see a lot of that in the coming months. Another really important topic is identity and provenance, right? There's a lot of discussion going on right now about the ability basically to look at a given container and then trace it back to a developer, a build, basically be able to scan exactly what's inside that container and make a decision of trust, right? Do I know the origin of this container, and can I trust it? Can I trace it back to a specific Git hash, right? Can I trace it back to a specific set of system packages? And that requires additional hooks. And it requires things like the ability to sign containers and the ability to manage a key ring of keys, signing these containers, et cetera. This is all something that's being built right now. So in the 1.3 release, we're introducing, which is the September release, we're introducing the notion of an engine key pair. So every single Docker engine, whatever the machines it installed on, is bundled with a key management system, which is accessible through the Docker API. And the reason I'm opening this thread here is we are in kind of the early design phase of that, of what will be built on top of that. So I encourage you, if this is a topic that's interesting to you, to come see me or come in IRC and basically list your demands. Tell us exactly how you want to use this feature, how you want to sign and identify containers, and especially if you have an existing system to integrate with. And the last topic, which is kind of linked, is based on this information on identity, we want to allow really advanced and complex ways to express which container can do what in relation to which other resource in your system, right? So this is really, think of that as a stack that we're building up. Again, each of those components you can use independently of each other. And again, this is a topic that we're looking for as much input as possible on. So ideally, for the developer, the result is this. We've got this magical toolbox, and as a result, the process of building these applications is much, much easier. But if you want one piece, you can use it in isolation. And that's really the takeaway. Other than that, we're on IRC. This is really where the heart of the project is. I think there's over 1,000 people there now. It's very active. I'm proud to say people are very nice and welcoming. There is no IRC snark in there. So you guys know what I'm talking about. So I encourage you to come and talk about it. It's an ongoing process. We're really trying to catch up to the community in terms of quality and features. But yeah, we really want to make this a solid foundation. So I look forward to talking to. Thanks a lot.